We already know that a relation is just a set of ordered pairs, and now we're going to talk about what a function is. A function is a relation or set of ordered pairs where each element in the domain, so each element in X, corresponds to one element in the range. That would make it a function. So here Bob is 18, John is 20, Bill is 21, and Mark is 20. Each student is only one age. So this is a function because each element in the domain has only one element in the range. On our next example, it really wouldn't make sense, but Bob is simultaneously 18 and 20. So Bob cannot be matched to two different ages. So this is not a function. Even though John is only one age and Bill is only one age and Mark is only one age, this is not a function because Bob is having some serious issues and is both 18 and 20. Here, we're going to determine if each of these relations represents a function, and if it is a function, we're going to talk about the domain and range. So first thing we're going to do is look at the x values. So what I'm looking for is if I have a repeating x value. And looking at this, I've got an x value of 1 here that corresponds to 3. And here I've got an x value that corresponds to 8. So 1 would map to 3 and 1 would also map to 8. And therefore this is not a function. We can't have an x value that goes to more than one y value. If it does, it's not a function. Let's look at our next example. Looking at all of these x values, I don't have any y values, don't have any x values that repeat or that map to more than one y. So this one is, yes, it is a function. The domain, remember, would be all of the x values. So least to greatest, -5, -2, 0, oh, I'm going to start getting confused, -5, -2, 0, 1, 9, and 11. We like to write those least to greatest. The range, again, least to greatest, would be -4, 0, 2, 2 again, we don't have to write it twice, 5, and 6. For our last one, again, we're looking at the x values, and it looks like we don't have any x values that repeat. So this one is a function. A lot of people get confused at this one because they see the 7, 7, 7, and 7 and say, well, that couldn't be a function. But we don't care what's happening on the y side. We only care that there's x's that go to only one y. So the domain here is all 4 of those values, -3, 2, 4, and 9. The range is all of the y values, which is really just 7, because 7 happens each time. So that was finding whether or not it was a function based on ordered pairs. Now we're going to determine if it represents a function based on the equation. So on an equation, I'm looking at this first one, and this is a linear equation. How do I know it's linear? Because hopefully at this point you recognize that this is in slope-intercept form. And slope-intercept form is a nice straight line, which means every time I plug in x, only one y is going to come out. So this, yes, is a function because it's linear, and every x is only going to result in one y. On this one, I've got sort of a problem here based on this. This is not linear because we can see this is x to the second power. That makes it not linear. Now there are some things that are not linear that are still functions, but we have to sort of, maybe guess and check a little bit. So if I plugged in 1, I would get y equals plus or minus 1 squared minus 6, which means if I used the positive, it would be 1 squared and positive, so that would be 1 minus 6, which is -5. If I used the negative, because that's plus or minus, I would end up with -7. So by plugging in 1, I got out both -5 and -7, so this is no, not a function. To test on a graph is actually the easiest thing because you only have to do the vertical line test. And the vertical line test says if you can draw, wow, let me try that again. If you can draw a vertical line straight up and down and only ever hit one point at a time, then it is a function. So yes, this is a function because I'm only hitting one point. So here I cross the line here, I cross the line here, and I cross the line here. On my second one, however, if I draw a vertical line, notice that first line I drew touched the graph in two places. So this is not a function because it failed the vertical line test. And my last one, same thing. I've got a circle. See how I'm going to hit 2 points? So this would be not a function. There's an x value that results in more than one y value. And that's exactly what we just said. This one is for you to try. We're going to determine whether or not all 4 of those represent functions. The first one, again, that's where I focus on my x values. I see here that I've got a 2 that maps to 4 and a 2 that maps to 8. So that is not going to be a function because x goes to more than one y. My equation, I've got x squared, which makes me a little bit nervous, but if I plug in, and as you go further in this course, you will find that an x squared just means that when I graph it, it's going to be a parabola. This one actually is going to be a function, but again, you can test it by plugging in some points. If I plug in 1, I end up with a value. 1 squared is 1, minus 3 is -2. And it doesn't matter if any other values result in -2, it just matters that when I plug in 1, only one result comes out. So this one, yes, is a function. Down here, if I look at my vertical line test, you see every time I'm only ever hitting 1 point. So this one, yes, is also a function because it passes the vertical line test. And my last one is a mapping, and on a mapping, I'm looking for if any value that's x has 2 arrows coming out of it, which they don't, so this actually is also a function.